In the last video, we finished up looking at the properties of a probability density function. And these two properties are chiefly that they're all greater than 0, or well, 0 or greater, which means our graph is always above the x-axis. Therefore, if you draw a graph and it goes like this, for example, then this can't be a probability density function because it goes below the axis. Okay. Also, we're told that if we find out the area of the graph between, well, of everything, between minus infinity and positive infinity, that the area of the graph will always equal 1 whole because it's probability, and it always does. Now, these are very key, very key facts to our next game show, the world's worst game show, probability density function or not a probability density function. Cue round of applause, big lights, etc. Standing ovation from the audience. So here's our first problem. Okay, now this is called a piecewise function. Okay, it is describing our probability density function, and it's broken down into pieces. Okay, so this says for us that between the values of -1 and 1, our probability is described by x to the power of 4. Outside of this range, our probability is going to be 0. So our first bit is to check our first condition, okay, which is this one here. We're saying the graph doesn't go below 0. So to do that, we can sketch it. So what we can do is our function of x. There's our x. So between -1 and 1, what the graph looks like. So either side of that, we're told it's got a value of 0. Now, if you find some values between -1 and 1 for x to the power of 4, you'll find that the graph does something like this. Okay, at no point is it going down below the axis. So first of all, we can check that the function of x is bigger than or equal to 0, and we say yes, it is. Therefore, it's a first indication that it's going to be a correct probability density function. Next thing to check. So the second of our properties is that the area equals 1. And that is going to be a lot of fun. So we need to check that the area under the graph between infinity and minus infinity is going to be 1. To do this, okay, we need to split this into the ranges given by the piecewise function. And you can see these bits in our graph as well. So the bits in our graph are either side of the 1 and -1, and then the bit in between as well. There's our 3 distinct sections. So we need to find out the area, and you have to write this all down, by the way, between -1 and infinity for the function. Add to that between the area between 1 and -1, and add to that this area up here between infinity and 1. And what's really nice is from our piecewise function, between these 2 points, we're told it's going to be 0. Between these points, using x to the power of 4. And between these 2 points here again, it's going to be 0. If we integrate that, well, they're going to be 0 anyway. We're left with increase the power by 1, divide by the power, and it's between 1 and -1. Right, I'm going to go along here just for space. Make sure you always work down your page though. So we're going to have 1 to the power of 5 over 5, take negative 1 to the power of 5 over 5, which is going to be a fifth plus a fifth, which is 2/5. Right, that does not equal 1. So the area under this graph is not 1, therefore this is not a probability density function. Right, I would like you to try one and establish whether this is a probability density function. Remember, the first step, try and sketch it, check it doesn't go below the axis. Second step, integrate it in the separate parts. So here it's between negative infinity and minus 2 and 2, and 2 to infinity is your 3 parts. And it can be more than 3 parts sometimes. And again, you need to integrate each bit separately and then see if it sums to 1. So pause it, give it a go. Right, first check. I say right a lot. First check, okay. Check fx bigger or equal to 0 between these two values. You know, apart from that, it's above 0. Hopefully you sketched it out. We've got minus 2, 2, and the graph will be 0 either side. And between them is a negative linear function. You can substitute in minus 2 and 2 into this to get the height of it, and it goes like that. So fine, happy with that. Satisfies the first condition. The second condition, that when you integrate it for the full range, you're going to get 1. So our 3 pieces. Our first piece is between this section, between minus 2 and negative infinity, and at that range is 0. Our next section is a middle bit between negative 2, between 2 and negative 2. And there, it's the probability is defined by that, or function is, shall I say. And the last section is anything that side, which is between infinity and 2, and again at this point, it's 0. Right, these are going to still be 0 when you integrate it, which leaves us with this section. Expand the brackets first. So 3 over 12 minus x over 12. Integrate that. Now what am I doing? Sorry. Take the 1/12 outside. Integrate the middle bit, which is 3x minus x squared over 2, and we're doing it between those two values, which gives us, keep the 12th outside, makes life a little bit easier. Substitute in 2, which gives us 6 minus 2, and substitute in a negative 2, which gives us negative 6, take 2, which is a 12th of 4 plus 8, which is, count down here, a 12th times 12, which is 1. Therefore, it satisfies both conditions, and we can say that this indeed is a probability density function.